Okay, I have received a question um, relating to basically switching among all of the different bases that we're working with. And as a reminder, we're working in bases 2, 8, 16, as well as base 10. And so let's start. I'm going to start out here with an example of a number n that's in base 2, which is represented by 1 1 0 1 1 0 0 1 0 1 1 1. And let's see, I'll do just 1 0 0 0 1 1 1 0. There we go. Just to make it challenging. And so I'm first going to take this, and it's clearly in base 2. I'm going to switch it to base 8. And to get it in base 8, remember, we break it down into segments of 3 bits. Okay. Right, and I have this left over up at the top. We'll deal with that at the very last. So what I can do in getting it in base 8, I look at these last 3 bits, and that's 6. Okay. How can I tell it's 6? Because this is 1, 2, 4. We go up by powers of 2, so this is 4 plus 2, that's 6. The next spot we're at is this is a 1, right? 0, 0, 1, that's a 1. This right here, it's a 6 again. This right here, this is a 0, 1, 1, so that's 2 plus 1, which is 3. This is 1 again. And this is, okay, a 4 plus a 1, which is 5. And this last up here, it's just a 1, so we pad it out 0, 0, 1, and so on. So in base 8, okay, and I guess I would write it as 0 little o, 0 little o, 1, 5, 1, 3, 6, 1, 6, or I would write it 1, 5, 1, 3, 6, 1, 6, base 8. Okay. Now, how do I get it in base 16? Well, okay, we take the same number, but instead of grouping it in groups of 3 bits, I will group it in groups of 4 bits. So 1, 2, 3, 4, 5 groups. And just to help a little bit here, A is equal to 1, 0, 1, 0. B is equal to 1, 0, 1, 1. C is equal to 1, 1, 0, 0. D is equal to 1, 1, 0, 1. E is equal to 1, 1, 1, 0. And F is equal to 1, 1, 1, 1. Okay, so in looking at this number in base 16, I look at the last 4, which would be, it's going to be E. Then it's going to be 1, 0, 0. Well, that is 8. 0, 1, 1, 1. That is 7. 1, 0, 1. That is 9. And then we have, let's see, we have 1, 1, 0, 1, which is D. All right, so we 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, I've got them all. And so in base 8, we were this, and in base 16, we are here. Okay. Now we come to how would I take this number and put it in base 10? And in some way, this is the hardest way of them all. But what do? Well, we pretend like it's a polynomial and we're evaluating a polynomial. And what polynomial do we evaluate? Well, to me, it seems like the easiest thing to do is look up here at our base 8 representation, and I'll have 1 times x to the, let's see, 0, 1, 2, 3, 4, 5, 6, x to the 6th power, plus 5 times x to the 5th, plus 1 times x to the 4th, plus 3 times x cubed, plus 6 times x squared, plus x plus 6. Okay. And I'm going to evaluate that polynomial for x equal to 8 because, again, this is in when we're using base 8, it's just as if we have 8 for each x there. Okay, so I will evaluate using the synthetic division method or Horner's method. We go 1, 5, 1, 3, 6, 1, 6, which again, just copying down the digits from the base 8. I'm going to evaluate it at 8. Bring down the 1. 1 times 8 is 8. 8 plus 5 is 13. I then say, oh my God, 13 times 8. And at this point, I'm helpless. I bring out a calculator. 13 times 8 is equal to 104. 104 plus 1 is 105. 105 times 8 is 840. So this is 843. 843 times, let's see, Claire. 843 times 8 is equal to 6744. Okay, well, 6744, and then I add 6 to that, and so this would be 6750. Okay, 6750 times 8 is equal to 54,000, and so we'd have 54,001 times 8, which is 432,008 plus 6, so that's 4,302 and 14 there. So this is what it is in base 10. Okay.